Hello and welcome to my channel. So today we shall move on to our next subtopic, which is exponential equation. Exponential equation. So what do we understand by the word exponential equation? Let's start with the word exponent. What do we understand by the word exponent? Exponent means power. Exponent means power. And for an equation to exist, it means that an equality sign must be included. If an equality sign is not included, then we cannot call it an equation. We may call it an expression. So, for example, now, um, exponential equation now focuses more on us looking for the unknown, and the unknown happens to be our power or exponent. Now, in this case, you can see that our unknowns here happens to be our power, which it can also be referred to as what? Exponent. And it can also come in form of a base too, as in our unknowns can also come or be in form of a base that we need to find. So how do we go about it? Let me just do a quick summary that exponent means power, and it becomes an exponential equation because of what? Because of the equality sign that is included in our problems or in what we want to solve. So let's look at the questions and let's analyze them one after the other. Now let's look at the first question. 2 raised to power x equals to 8. So how do we solve this? What we should do or what we should observe is this. Look at your left hand side and your right hand side. Now, if you can try as much as possible to make sure that you are able to reduce this 8 to what is called lowest common base. Now you can see that this is 2. So automatically I can as well reduce this 8 to a number that when I raise it to the power is going to be equal to my base. Let me take this. Let me um repeat this. This is 8. So what am I going to do? I'm going to reduce this 8 to its lowest common base in such a way that this number and this number that will be reduced to will be the same. So what is my aim? My aim is to make sure that the base are equal. That is my aim. So from here now, I can see that the base here, the lowest base I can see on my left hand side is 2. So the trick here is always what? Make sure this 8 is reduced to a number, which is this 2, in such a way that when you raise it to its power, it becomes 8. So we have 2 raised to power x equals to 2 raised to power 3. So what do we observe? We have seen that the base here are equal. In this situation, we are only going to equate powers. So I will say equate powers. Why are we equating powers? We are equating powers because number one, our unknown is x, and automatically x is equal to our answer here. And secondly, when the base are the same, then it means that what? It means that we are going to focus on the power. What does it mean for base to be the same? It means that they can cancel out, and what we need here is what? Is the power. So when you equate powers, x automatically equals 3. Let's move on to number 2. 3 raised to power 2x equals 81. Now, what is our left hand side? 3. So the trick here is try as much as possible to reduce 81 to 3 raised to power something in order for the base to be the same. So it's going to be 3 raised to power 2x equals to 3 raised to power 4. So, and you can see that the base are the same. So we focus on the what? On the power. So I'll just write equates powers. So we have 2x equals to 4. Then we want to make x stand alone. We divide both sides by 2. So we have 2x over 2 equals 4 over 2. Then 2 cancels 2. Here 1, here 2. Automatically x is equal to 2. So let's move on to number 3. Number 3 is x raised to power 1 over 4 equals 3. So in this case, the base is the unknown letter here, but we have power 1 over 4. What are we going to do? Our aim is to find value of x. If you look at the first question, we're able to achieve by finding the value of x. Look at the second one, we were able to achieve our aim by what? Finding the value of x. So same goes to number 3. So how do we find the value of x? Our way of finding the value of x in this situation is to make sure our aim is to make sure x is raised to power 1. And let's not forget that when x raised to power 1 is automatically x. So what do we do? The only way we can do that will make this to be equal to 1 is if I should multiply both sides by its reciprocal. I said it in one of my videos that has to do with multiplying both sides by its reciprocal in order to make that value on that area to be equal to 1. So x raised to power 1 over 4 times 4. Not supposed to be 4 over 1, but I can as well leave it as 4 equals to 3 raised to power 4. So when 4 cancels 4, I will have x raised to power 1 automatically, and equals to 3 raised to power 4 is 3 in 4 places, and that is equal to 81. So automatically x equals 81 in this question. Then let's look at the last question, which is the fourth question. How do we go about the fourth question? For the fourth question, 4 raised to power x equals 128. Now, what I said, the method used for number 1 and number 2 was quite easy. Why? Because I know that the lowest common base is 2, so I can as well take this 8 to 2 raised to power something. I know that the lowest common base here is 3, so I can as well take 81 to 3 raised to power something, because my aim is to make sure that the base are the same. Now in this case, now what are we going to do? If I should make this 4 raised to power something, automatically I will never get 4 raised to power something that will give me 128. So what are we going to do? What we are going to do here is to reduce this to a common base. So what I'm going to do now is that I can as well reduce this 4 to 2 raised to power 2. And let's not forget that there is x here before, equals to 2 raised to power that is 7. Yes, 2 raised to power 7. Now I know that like what I've done so far, I was able to take this one to 2 raised to power 3, because I know that the lowest common base here is 2. I was able to take this one to 3 raised to power 4, because I know that the lowest common base there is 3. And I would have done the same for 128, but the problem here is that 4, I cannot take 4 to a certain number that at the end of the day, when I multiply it out, it gives me 128. So what I'm going to do now is to just reduce these two numbers to a lower common, or to its lowest common base, and its lowest common base is 2. I know that 2 raised to power 2 will give me 4, and 2 raised to power 7 will definitely give me 128. So from here, I can see, since that the bases are equal, then I will go ahead to equate powers. And I will have what? 2x equals 7. And automatically x equals 7 over 2, or 3 over 1 over 2. So that is my answer. So on this note, we stop here. And in our next video, we are going to solve questions on exponential equation that is reducible to quadratic equation. Thank you, and see you soon.